Good afternoon, my YouTube viewers. It is Crystal here, and I'm just here this afternoon because I want to do a code review with you. I entered a Kaggle competition and feedback prize predicting effective arguments, and I didn't score very well, but I used a new technique on it, and since I used a new technique on it, I decided that I was going to go ahead and do a code review. So you can take my code, you can take this technique that I have used, and you can use it to build your own code, and maybe you can improve upon that code as well. So you can see that the best score was 11.146, which wasn't very good, but I did get on the leaderboard, so that's saying something. So what we'll do is we will read the problem statement. The goal of this competition is to classify argumentative elements in student writing as effective, adequate, or ineffective. You will create a model trained on data that is representative of the 6th to 12th grade population in the U.S. in order to minimize bias. So that's what the task is. That's the problem statement. And so what we did was we created this program on using a Kaggle Jupyter Notebook. And so whenever we created the program, the first thing that we needed to do was we needed to import our libraries. So we're going to import NumPy as NP, and that allows you to perform numerical calculations and create NumPy arrays. We're going to import Pandas as PD, that allows you to create and manipulate data frames. We're going to import Matplotlib PyPlot as PLT, and that allows you to plot the data points onto a graph. And we're also going to import Seaborn as SNS, and that allows you to plot the data points on a graph, but do it in a statistical fashion. So it has a little bit more power to it than Matplotlib does. So after we've imported our libraries, we're going to load our data set. So we're going to import OS, and for dir name, file names in os.walk Kaggle input for file name and file names. I said if the file name ends with CSV, you're going to print the DRR and the file name. So basically what I did was, because there were loads and loads of text files in there, and so the text files were just going to eat up the page, and all you would see was text files. So what I did was over here, I made it, this point here, I made it that it would only print it if it was a CSV file, but there are lots and lots of text files. Then we're going to use Pandas to read the files. We're going to read the 3 files in train, test, and submission. So you can see the train has a discourse ID, essay ID, discourse text, discourse type, and discourse effectiveness. And you can see that the discourse effectiveness is your label or your target, and you can see that it's categorical, but it's also a string. So at some point, these categorical values are going to have to be converted from a string to a number. And so you can see the text only has 10 rows of data, so it's not very much to predict upon, but it doesn't have a label. So that's what we're going to have to do. We're going to have to predict upon the label. And you see the submission file. So you'll see over there on the train file, the the target or the label only had 1 column of data. And so what they're going to do is they're going to convert that 1 column of data to 3 columns of data. So when we go to predict upon the label or the target, then what we're going to have to do is we're going to have to use a multi-output function to do that, to give you 3 outputs. In addition to that, we're also going to have to do like one-hot encoding to convert the 1 row of categorical data to 3 rows of data. So that's what we're going to be doing. So now we're going to analyze the target. You see that the most of the points were adequate, and the next was effective, and the least was ineffective. So this is going to be an unbalanced target. So it also is going to need to be balanced as well. Now what we're going to do is we're going to replace the string with a number, and what that's going to do is that's going to enable us to make predictions, because sklearn's models or regressors will not predict on a string. And in addition to that, even though the target is a categorical value, and it seems, and because it's a categorical value, it seems like it's going to be, it seems like it's going to be something like a logistic regression or something like that. The fact is that in the submission, they don't want it to be categorical, they want it to be numeric. So that's another problem that we're going to have. And what that means is, instead of a classifier in the model, we're going to have to use a regressor. So that's another problem that we have, because your label is actually a classification, but we're going to convert it to a regression. So that's what we did in this line of code here. We replaced the objects with numbers. Now what I did was I did a box plot, and so you can see the box plot. You can see 1 is at your bottom, 2 is on the middle, and 3 is the top, and it's also going to be, you have the fewest outcomes on number 3, the most outcomes on number 2, and the second the most outcomes on number 1. So now what we're doing is we're just looking at the value counts. So you can see you have 20,977 on 2, 9326 on 1, and 6462 on 3. And now we're going to look at the percentages. You have 57% on 2, 25% on 1, and 18% on 3. And now what we're going to do, we're going to read the train and test papers into the program. And what the papers are doing, the papers are in either train or test. So what I had to do is had to create a new column for the train and the text files, and then we had to use a lambda function. So train discourse paper equals train SAID dot apply lambda x, and then you're going to open the text file and read it. And you're going to do the same thing with the test file. So you can see now we have a new column, and the new column is your discourse paper. Now we have to define the target. Target equals train discourse effectiveness. Now what we're going to do is we're going to combine train and test. And so combi equals train draw discourse effectiveness, axis equals 1, append test. So we're dropping discourse effectiveness from the train file, and we are appending test to the train file. So now you can see that test is appended to the train file. So I just wanted to analyze discourse type. I didn't really use it whenever I initially made this program. I wanted to use the discourse type, but in the end I decided not to use it. It didn't really make any difference. if I didn't use the discourse type, so I didn't use it, but I went ahead and left the analysis in there. So this is a displot of your discourse type, and you can see again that's not very balanced either. So we checked the value counts of the discourse type, and so you can see how many discourses you have for evidence, claim, position, concluding statement, lead, counterclaim, and rebuttal. And then we also checked the percentages. So you had evidence and claim had similar amounts of percentages, and then everything else was much smaller. Now what we're going to do is we're going to define our text. So text equals COM-B discourse paper. We're going to count the words that we have to process, and I think it is 17 million words. I think it is. So that's 1, 2, 3, that's hundreds, 1, 2, 3, that's thousands and millions. So that's 17 million words it has to process. So now we're going to process the text. We're going to import read, and then we're going to import NLTK. So we're going to convert all of the text to lowercase, and then we're going to remove the special characters from text. We're going to remove the hashtags. We're going to remove the words less than 2 characters. We're going to remove the stop words, and we're going to count it. And now it's halved. Now the number of words that it has to process are halved, basically. Less than half, really. We're going to remove the most frequently used words because the most frequently used words don't add a lot of meaning to the interpretation, so we remove the most frequently used words. And then we're going to put in an apostrophe dictionary, and what this apostrophe dictionary does is it takes all the words with apostrophes and it just gives you the words spelled out without the apostrophe. So that's our apostrophe dictionary. We're going to now we're going to create a function, and what this function will do, it will take all of the words that are apostrophes and it will replace those words with words that are spelled out, and we will do that by using this lambda function. Now what we're going to do is we're going to remove rare words, and the reason why is a rare word is going to add little meaning to the interpretation. So we still have, like, we've got 1, 2, 3, we've got now 6.7 or 6.8 million words that it's got to analyze. So that's about 2 million words less than previously. Now we're going to define our x and our y variables. Y equals pd.getDummiesTarget, and what that does is the getDummies takes the one column and it converts it to 3. And then x equals COM-B len train, and x test equals coming from the length of train to the end. So you've got your x and your x test. So now we can see y. So now instead of y being 1 column, it's now 3 columns. So now what we're going to do is we're going to use sklearn to vectorize the words. So from sklearn.featureExtraction.text, import tfidf vectorizer. Vectorizer tfidf equals tfidf vectorizer. Stop words equals English. Max df equals 0.5. Min df equals 0.01. So x equals np array x to list. So it's going to take the words and convert them into a list. X equals list map join X. So it's going to take the words and it's going to join the words that are on the list. And X test, it's going to do the same thing with X test. So what I did was, normally what you would do is you would split the test set into training and validation sets, but I decided not to do it on this occasion, and the reason why is because I didn't have any graphing to do, and because I didn't have any graphing to do, I decided not to do it. So TF-IDF equals vectorizer TF-IDF fit transform X. X test TF-IDF equals vectorizer TF-IDF transform X test, and then it says you print vectorizer TF-IDF get feature names. So we printed that out. Now we look at the shape. So now the shape of the X is 36765 rows with 20 columns, and X test is 10 rows with 20 columns. Now what we're going to do is we're going to select the model, and we had to use a multi-output regressor, and I decided to use K-neighbors regressor. Model equals multi-output regressor K-neighbors.fit X TF-IDF Y. Print model score X TF-IDF Y, and that gives you about a 46% accuracy, which isn't very much, but as I said, I decided to go ahead and do a code review on this because I used some different bits of code, and since I used some different bits of code, I wanted you to see that. Now we're going to predict on the X test. So we predicted on that, and you can see that you got 10 rows of data with 3 columns for each row. And now what we're going to do is we're going to prepare the submission. So prediction, we created a data frame that had the columns ineffective, adequate, and effective. And then prediction, discourse ID equals submission discourse ID, and then titles equals discourse ID ineffective, adequate, and effective. Prediction equals prediction dot reindex columns equals titles, and then prediction. So this is your prediction, and it's set up like it's going to be in the submission data set. And the reason why I did it that way is because I had originally been working on this on spaCy library, and what happened was no matter what I did to try to save my work, it failed. And the reason for that is because when you save your work, you have to save it with the internet off. And when you save it with the internet off, because spaCy isn't automatically uploaded into the Kaggle Jupyter Notebook, it would fail. And so I was just trying anything and everything to get it work till last night, late last night, and then early this morning, and then I finally just decided to use sklearn. And when I used sklearn, the file would save with the internet off, but I thought, well, I'm not changing everything around, so that's why I've done it this way, because what I was doing is I was troubleshooting. I was trying to figure out ways to get it to work, but the problem is because spaCy is not loaded in Kaggle's Jupyter Notebook, you have to save it with the internet on, and for that reason I couldn't use spaCy on the competition, because it just wouldn't save. Whenever I tried to save it, it would fail. So that's why it looks so strange. And now submission equals PD data frame prediction, submission to CSV, submission CSV, index equals false, submission. And so now we've got our submission. And this is what I submitted to Kaggle. I had 11.146, but what I will do is I will show you everything I did. I'll show you my submissions. So I'm 331 out of 334, so I didn't do very good. But at least I did something, you know. Give me an A for effort. So this is what I've done. So I tried sklearn, which was 9.580, and then another sklearn, which was 9.491, and then we did the sklearn text file, which was 11.146. So I could have showed you 9.491, but if I had done that, then you would not have seen how I loaded the text file into the program. So you can see all of my submissions, and I didn't do very good. If I have the time, which I probably don't have the time, I could go look at other people's code and see what other people did to improve their score. But I'm under a lot of pressure to do blog posts and courses with Udemy. And then so I made these code reviews to accompany my blog post. So that's why I'm not doing very good. I mean, if I had the time and I wasn't under a lot of pressure to create content, then I could just sit there all day long looking at people's code and going through the code and seeing what I can do to improve my code. And that's basically how people win the competitions. People win the competitions by, whenever some new code comes out, they look at that code and they see if there's anything in that code that they can put in their code to actually improve their score. But I don't do that because I don't have the time. But I do think that even though I didn't do very well on the score, I think that I did a good job with the Jupyter Notebook. So I showed you the logic of my work, and I didn't give you any spaghetti code. It was very thought out, very organized, very methodical. So even though I didn't score very well. But what you can do is you can take my score and you can see if there's any, take my code, you can see if there's any of my code that you can use to improve your score and make you a better programmer. So I think I'm going to close now because I've done the code review. I'd like to thank all of my subscribers for supporting my channel. If you like this video, please like, subscribe, and share. And I would like to thank you for watching my video. And I look forward to making more videos for you in the future.